Hey guys, today we're going to be looking at Module 15, which is 15.1, Mean Absolute Deviation. The text that we're going to be focusing on is 8.11b, which is determine the mean absolute deviation and use this quantity as the measure of the average distance data as from the mean using a data set of no more than 10 data points. We're also looking at the process standard of 8.1c. Okay, a lot of vocabulary is needed to be successful in this lesson. First vocab word is measure of center. This, if you remember from last year, is the same thing as measure of central tendency. Our measure of center are 3 M's, mean, median, and mode. Okay, remember mean is the average, median is the middle number of our data, and then mode is the data piece that happens the most often. Okay, another vocab word is the mean, which we just talked about, and that is just the average. So we have to add up all of our data values and then divide by the number of values in that data set. So for instance, if I'm looking at these data values, 60, 58, 54, 56, 63, 65, 62, 59, 56, and 58. I want to calculate the mean and round to the nearest whole number. So again, we're trying to figure out what the mean is. So remember, the mean is the sum of the data, sum means the answer to an addition problem, divided by the number of values. So what I need to do is I need to add all of these up. So I'm going to add 60 plus 58 plus 54 plus 56 plus 63 plus 65 plus 62 plus 59 plus 56 and plus 58. I need to figure out the sum of that and then divide it by the number of values. So first of all, let's divide it by the number of values that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to be dividing by 10. So when I use my calculator, I'm going to add those up, and I should get 592 as the numerator. 10 is still the denominator. And when I divide that out, I get 59.2, but remember, we want to round to the nearest whole number. So that would actually round to 59. So my mean for this data set is going to be 59. Okay, some more vocab that's really important is deviation. Now deviation is just another word for the distance that the 2 points are separated from each other. Okay, now what this actual TEK is all about is our deviation from the mean. So again, deviation, I always think of just the word distance. Deviation from the mean is how far those data point is from the mean, and to find that distance we're going to subtract the two values. So it's really just distance from the mean. Okay, so since we already have our mean, now we need to figure out what the MAD is, which is the distance from the mean. So with each of our data values, 60 was my first one, 58 was my second, and so forth. I need to figure out the distance from the mean for each of these values. So if I'm looking at 60, okay, the difference between 60 and 59, okay, is just 1 away. So my answer is going to be 1. Now if I look at 58, from 59 to 58, I'm still going to have the distance of 1. Now remember, our distance is always going to be positive. It's sort of like taking the absolute value of these numbers. Every time our answer is going to be a positive outcome. So the distance from 59 and 54 is going to be 5. The distance from 59, which is our mean, and 56 is 3. The distance from the mean 59 and 63 is 4. So each one, I'm going to write down the distance from the mean. So I'm going to have for 65, it's 6 units away, 62 is 3 units away, 59 is the mean, so it's 0 units away, and 56 is 3 units away from the mean, 58 is 1 unit away from the mean. So that's the deviation from the mean, is the distance away from the mean. Now, our MAD, which is our mean absolute deviation, which is ultimately what we're trying to find, is the average distance of all the data points from the mean. So what we just found up here, again, was our distance of the mean. If you look at this definition, now it's just the average from all these points that are distance from the mean. So now what I have to do is I'm averaging all of these points. So when I add all these together to calculate the mean absolute deviation, or the MAD, I'm going to add up all the distances from the mean. 1 plus 1 plus 5 plus 3 plus 4 plus 6 plus 3 plus 0 plus 3 plus 1. Again, average means I'm going to divide by the number of data values I have. So in this case, I still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to find the sum. When I add those, I get 27. I'm going to divide by 10, and I should get 2.7. However, again, it says round to the nearest whole number. Okay, so my answer here is that the MAD, or our mean absolute deviation, is 3, which is the average distance of all the data points from the mean. That's the average distance for the most part. Okay, let's look at a real-life example now with an actual word problem. Okay, this problem says a chicken farmer wants her chickens to all have the same weight. She is trying 2 types of feed to see which type produces the best results. All the chickens in pen A are fed premium growth feed, and all the chickens in pen B are fed maximum growth feed. The farmer records the weights of the chickens in each pen in the table below. Which chicken feed produces less variability in the weight? So we're trying to figure out at what point is our mean absolute deviation going to be less. Is it going to be less with pen A using premium growth feed, or is it going to be less in in pen B, which is the maximum growth feed? Which MAD, or mean absolute deviation, is going to be less? That's going to control the variability. Okay, so the less MAD, or the smallest MAD. Okay, so flip your paper over. Okay, the data set that it gives you, if you look, pen A, these are the weights of the chickens that use this feed, and pen B is the weights of the chickens that use the maximum growth feed. So first step to figure out the MAD is to figure out the mean for each pen. So again, we want to round to the nearest tenth this time. So not whole number, we're rounding to the nearest tenth. So to find the mean, I need to add up all my data values and divide by the number. So go ahead and take a second to do the mean for both, and then pause it and check with mine when you're done. Okay, you should have added for pen A 5.8 plus 6.1 plus 5.5 plus 6.6 plus 7.3 plus 5.9 plus 6.3 plus 5.7 plus 6.8 plus 7.1. Okay, I'm going to add those all up, and I'm going to divide by the number of data that I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to enter that in my calculator, and I should have gotten 63.1. But remember, I'm dividing that by 10, so my answer here is 6.3, and that's rounded to the nearest tenth. So the mean of my data values in pen A is going to be about 6.3. That's fairly the average between all of them. Okay, same thing for pen B. I'm adding up all my data values, 7.7 plus 7.4 plus 5.4 plus 7.8 plus 6.1 plus 5.2 plus 7.5 plus 7.9 plus 6.3 plus 5.6. Again, I'm counting up the number of data sets that I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to divide all that by 10. I'm going to use my calculator and add up all the weights of the chicken, or my data. I'm going to get 66.9. I have to divide that by 10. I end up getting 6.69, so I'm going to round to the nearest tenth, which is 6.7. So the average for pen B is going to be 6.7. Okay, my next step here after I find the mean is I need to find the distance from each of the data sets in pen A and pen B from the mean. So let's look at pen A first. Okay, what was pen A's mean again? Okay, you should have said 6.3. So again, to figure this out, I need to figure out the distance from each of these points, or each of these weights, from the average weight that we found. So the distance from 6.3 and 5.8 is going to be 0.5. Remember, it's always going to be a positive outcome. So the distance is 0.5. Okay, the distance from 6.1 and 6.3 is 0.2. The distance from 6.3 and 5.5 is 0.8. And I'm going to continue. 6.6, the difference is 0.3. 7.3 and 6.3 is 1 whole. 5.9 and 6.3, the difference is 0.4. 6.3 and 6.3, there's no difference because it's the same number, so that's 0. The difference between 6.3 and 5.7 is 0.6. The difference between 6.8 and 6.3 is 0.5. And the difference between 7.1 and 6.3 is going to be 0.8. Okay, so I figured out all the distance from the mean. Let's figure out pen B at the same time. So pen B's mean, if you remember up here, okay, is the average of 6.7. And I'm going to find the distance of each weight, each chicken weight, from the average weight. So the difference between 7.7 and 6.7 is 1 whole, so 1.0. The distance between 7.4 and 6.7 is 0.7. The distance between 5.4 and 6.7 is 1.3. Okay, I'm going to continue that. 1.1, 0.6, 1.5, 0.8, 1.2, 0.4, and 1.1. Those are all the distances from each individual chicken from the mean weight of that pen. Okay, so our last thing is we need to calculate the MAD. Okay, remember that the MAD is the average distance from the data points to the mean. We just found all the distances from the mean, so now we have to average those together. So for pen A, I'm looking at my data sets from up here. Okay, so for pen A, I have 0.5 plus 0.2. These are, remember, all the differences from the mean. Plus 0.4, plus 0, plus 0.6, plus 0.5, plus 0.8. Okay, again, I'm going to add those up, divide by the number of data sets I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to round to the nearest tenth again. So when I add those together and divide by 10, I should get 0.5 as the MAD, okay, which again stands for the mean absolute deviation, okay, the average distance of all the points from the mean. Okay, pen B, I'm taking all of these distances again from the mean, so 1.0 plus 0.7 plus 1.3 plus 1.1 plus 0.6 plus 1.5 plus 0.8 plus 1.2 plus 0.4 plus 1.1. I'm going to divide that again by the number, which is 10 data sets. Add it together, divide by 10, and I get 1.0 as the MAD, as our mean absolute deviation, which is the average distance of all the points from the mean. So again, the question was asking us which chicken feed produces the less variability in weight. Okay, since pen A has the smallest MAD, okay, we know that since pen A's MAD is less, then pen A, which used the premium growth feed, produces a less variability in weight. Okay, a lot of work, a lot of data, a lot of calculations. Okay, we're going to have plenty of time to practice this tomorrow. But please make sure that you take the Sophia quiz and ask any questions when you first walk into the door tomorrow to your teacher. Have a great night, and we will see you tomorrow.